Okay, so good evening while I'm recording this one, and good morning while you're watching this video. No, so unfortunately, I cannot meet you today due to I have a talk, no, for the extension project this morning. But on the afternoon, we will meet to discuss the chapter 3. Then that would be the coverage of our midterm exam from chapter 1, chapter 2, and chapter 3. And the midterm exam is scheduled on Saturday. So for recap of what we've talked last Saturday is that we talk about the basic configurations of the devices such as the switch and router. We also learned how to download the Cisco Packet Tracer, and we are advised to download the latest version. And then we also configured the switch. We were able to configure the router and access a switch using a remote access through telnet and SSH. And we even distinguished the difference between telnet and SSH last meeting. So for today, we're going to talk about the switching concept. And for the introduction, we have here why should I take this module, and you can connect and configure switches, so that's great. But even network with the newest technology develops its own problem eventually, and if you have troubleshoot your network, you need to know how switches work. So this is very useful and applicable when you work on the industry as network administrator or assistant network administrator. So this module gives you fundamentals of switches and switch operations, and luckily switch operation is easy to understand. So what will you learn to do in this module? One is the frame forwarding, and then the switching domains, which we compare the collision domain to a broadcast domain. So to start with, we will talk about the frame forwarding, which is switching and networking. The concept of switching and forwarding frames is universal in network and telecommunications. So various types of switches are used in LANs and even in wide area networks or WANs, and in public switch telephone network or PSTN. So ito yung mga nakikita natin basically doon sa mga poste, no, na may lock or parang drawer na metal type. So like in PLDT and Converge. So those are the public switch telephone network. Yan din yung reason why sometimes when you apply for internet, the ISP or the internet provider eventually will reply to you that there is no available slots on your area. So probably the reason is the switch on that network or in that area, all of the ports were occupied. That's why there's no available account dun sa area nyo. Now the decision how a switch forwards traffic is made based on the flow of the traffic. Then there are two terms associated with frames entering and leaving the interface. So one is the ingress, with the keyword here when you say ingress, it's enter, that's why in. And then egress, it's when the frames leaves the device. So that's the very important keywords that you need to remember. When we say ingress, those are the frames that enters the device, and then egress, those are the frames who actually leave the device or forward to different devices. Now, a LAN switch maintains a table that is referenced when forwarding traffic through the switch. The only intelligence of a LAN switch is its ability to use its table to forward traffic. So we have the MAC address table that stored in a flash. Not to look for the specific address or the MAC addresses, the destination MAC addresses, so that the packets will be forwarded on that destination. Then a LAN switch forwards traffic based on the ingress port and the destination MAC address of an Ethernet frame. So take note that an Ethernet frame will never be forwarded out the same port it was received. So we have an example here of an animation. Take a look at the port table. We have EE, AA, BA. So these are example of destination addresses, and then we have the switch ports 1 to 6. So when we play this one, assuming that the ingress or the destination address from port 1, okay, it will forward to port 4. Again, it will not forward itself when where the frames were received. It will forward it to the different ports. So this is an example of how a switch process a frames or a data or a traffic that's sent from one port to the other port. Okay. So the switch MAC address is made up of integrated circuit. We have the and the accompanying software that controls the data path through the switch. So switches use destination MAC addresses to direct network communication through the switch out the appropriate port toward the destination. Again, it's very important that you know the MAC addresses of your devices. So one of the advantage of MAC addresses, for example, in a network, just like in CCS, as a student and faculty, the Wi-Fi in CCS doesn't contain any password. But again, even though there's no password required, you are not able to connect to the internet due to your MAC address is not recognized by the router or by the switch or the network. Now, to know your MAC address on your cell phone, you can go to settings and then the about phone, and then you will see there sometimes the MAC address or the physical address. So for computers, you just simply type you just go to start and then type CMD, and then you just simply type here, okay, get MAC. And as you can see, there are 4 MAC addresses presented here. One of those MAC addresses is my Wi-Fi. The other one is my fast Ethernet or the LAN port or the NIC. Then the other one is the Bluetooth. So that's how we get the MAC address of our computer or laptop. So for switch to know which port to use to transmit a frame, it must first learn which device exists on each port. Again, if the address is not existing or the device is not existing on the MAC address table, the switch has the capability to learn the addresses or the addressing table from other devices or other switch. So as the switch learns the relationship of ports to devices, it builds a table called the MAC address table. So this table is stored in content addressable memory, or what we call CAM, which is special type of memory used in high-speed searching applications. So for this reason, the MAC address table is sometimes also called the CAM table. So LAN switches determine how to handle incoming data frames by maintaining MAC address table, and switch populates its MAC address table by recording the source MAC address of each device connected to of its ports. So again, for example, let me draw a figure here. Example, this is your switch 1, and then there are known networks here. For example, this is PC1 connected directly to our switch PC2, and then let's say we have a router here, which is that this router connects to another switch here. Then if the switch wants to send message to PC1, so definitely there is no direct connection from switch 2 to PC1. The packets from switch 2 will travel going to our router, and then that router forwards the frame or the packets to our switch 1. Now switch 1, for example, it stores on its MAC address table or the CAM table the address or the network address of the router here, and then it will load now to its CAM table, so that the next time that router that will send the packets, it will already recognize by our switch 1, which again, every direct all the connections, directly connected devices to our switch, okay, the device, the MAC address are stored on our COM table. So from switch 2, the packets will travel to R2, from R2 going to switch 1, and then from switch 1, it depends if it's a unicast, multicast, or broadcast. So it will send now the packet through PC1. Sometimes it's multicast or broadcast. It will send the packet to PC1 and to PC2. So since the frame or the packet is intended for PC1, PC2 will not reply or sends a feedback. Rather, PC1 will now send a acknowledgement or feedback to S1, then from S1 going to router, then going back to S2. Then from there, we establish a communication or link from S2 to PC1. Okay, so the switch learn and forward method. So we have two steps. One is to learn. If the source MAC address does not exist in the MAC address table, then the MAC address and incoming port numbers are added to the table. So again, just like on our example earlier, if the MAC address is not recognized here, since S2 is not directly connected to S1, it will now save or be added to our table. So if if the source MAC address does exist, the switch updates refresh timer for that entry. So by default, most Ethernet switches keep an entry in the table for 5 minutes. Again, remember the time or the durations. If the source MAC address does exist in the table but on a different port, the switch treat this as a new entry. So probably from port 1, it was unplugged from the port 1 and then transferred to port 2. Then our switch will treat that as a new entry. Then the entry is replaced using the same MAC address but with more current port number. So that's the step 1, is learning the source MAC address. Now step 2 is forwarding, examining the destination MAC address. Now if the destination MAC address is in the table, then it simply forward the frame out of the specific port. And then if the destination MAC address is not in the table, the switch will forward the frame out all ports except the incoming port. So just like on our example here, we have 24 ports, and then we have one port used from the switch going to the router. It means we only have 23 ports, assuming that all 23 ports are occupied by different computers. So if the destination MAC address of this frame, for example, it's not listed or is not on the table, then the switch will send or forward that packet to all ports. So it means all 23 ports will receive the same packets or frame. And then this is called an unknown unicast. So remember that term. So if the destination MAC address is a broadcast or a multicast, the frame is also flooded out all ports except the incoming port, just like I've mentioned earlier. Okay. So this is just a example video of MAC address tables on connected switches. So you can play this one by logging into your NetAcad account and then go to 2.1.4 topic, video MAC address table on connected switches. So this I guess a 3-minute video. They will discuss here on how switches build MAC address tables. Okay, so switch forwarding methods. We have switches make layer 2 forwarding decisions very quickly. This is because of software on application-specific integrated circuits, or what we call ASICs. So ASICs reduce the frame handling time within the device and allow the device to manage an increased number of frames without degrading performance. So layer 2 switches use one of two methods to switch frames. One is the store and forward switching. It means that it makes a forwarding decision on a frame after it has received the entire frame and check the frame for errors using mathematical error checking mechanism, or what we call the CRC, or the cyclic redundancy check. So this is primarily a LAN switching method. So again, store and forward. It means let me delete this one. So when you say store and forward, example, the switch here has the storage from the definition. Okay, we have here the entire frame. Now the switch, okay, from switch 1 for example to switch 2, so the switch will not forward this frame unless it receives all the details or all the data that requires to be transmitted. So that's why they call it store and forward. So the switch will wait for the entire frames, to be stored before it forward it to the destination. Unlike cut-through switching, this begins the forwarding process after the destination MAC address of an incoming frame and the egress port have been determined. So for example, for cut-through, so let's remove this one. Okay. For example, for cut-through, it's a different method from store and forward. For cut-through, example, this is our frame. We've just received, let's say, 1/3 of the entire frames. But on that 1/3, the destination MAC address were already determined. Then the switch now will start forwarding the frames or the data or the packets to the destination device. So that's the difference between the store and forward and cut-through switching. So for store and forward, there's disadvantage or characteristics error checking. So after receiving the entire frame on the ingress port, the switch compares the frame check sequence, or what we call FCS value in the last field of datagram against its own FCS calculations. So again, there's an error checking. So what will happen if the frame check sequence did not match on its own frame check sequence? So the frame will be dropped. So these are the reasons sometimes when we download a file from the internet, and then there is a temporary download file, and then after downloading it, let's say after 2 minutes, suddenly the download was cancelled. So probably due to the error checking mechanism of our network. Next is automatic buffering. So the ingress port buffering process used by store and forward switches, it provides the flexibility to support any mixed Ethernet speed. So for example, handling an incoming frame traveling into 100 Mbps fast Ethernet port must be sent out a 1 Gbps. So would require using store and forward method. So with any mismatch in speeds between ingress and egress, the switch stores the entire frame in a buffer and then computes the FCS check, forward to egress buffer, and then sends it. So this is an example of figure on how store and forward switching entails receipt from the entire frame up about to 9,200 bytes for jumbo frames before forwarding decision is made. So we have here the CRC, and then preamble, the destination MAC address, the source MAC address, and then what is the type of this frame. Okay. So for cut-through switching, it's a different story. So for straight store and forward, as you can see here, it checks from the first byte or from the beginning of the frame up to the end of the frame. That's why there's an error checking mechanism inside the store and forward switching. Unlike cut-through, once the preamble was received and then the destination MAC address, this now will begin the packet forwarding to the destination MAC address. So for cut-through, the important thing is the destination MAC address, regardless if the frame contains some errors or there are frame drops. So that's the problem with cut-through. So by contrast, the cut-through switching method may forward invalid frames because again there's no error checking. Okay. However, cut-through switching has the ability to perform rapid frame switching. This means the switch can make forwarding decision as soon as it has looked up the destination MAC address. So the switch does not have to wait for the rest of the frame to enter the egress port before making its forwarding decision. Then fragment free switching is modified form of cut-through. in which the switch only starts forwarding the frame after it has read the type field. So again, there's another method, which is the fragment free. So from cut through, it will read up to the destination MAC address, but for the fragment free, it will wait for the type frame or type field to be read before forwarding the packets or the frame. So the lower the latency speed of cut through makes it more appropriate for extremely demanding high performance computing, so such as games, video conferencing, video call. So cut through is being used on that kind of communication. But for email, chat, we need store and forward. So before we forward the message, we need to collect the entire frame or data before sending it to the destination. So there's an example activity here. You can just simply check the questions. Then there's a given diagram or figure here. So for example, question 1, where will the switch forward the frame? Again, we have here the destination 0B and then source MAC address 0A. As you can see on the figure, the arrow pointing up from 0A PC going to the port FA01. It means this is the sender, and then that packet or that frame is to be sent to the destination MAC address 0B. Then upon looking on the figure, 0B PC is connected to FA03. So the question is, where will the switch forward the frame? So the answer basically is FA03, where 0B MAC address is connected. And then when the switch forwards the frame, and which statements are true. So frame is unicast frame and will be flooded to all ports, or frame is unicast frame. Again, when you say unicast, uni, it means one. It will send only on the specific port. When you say broadcast, it will be forwarded to all ports. Okay, so the answer is unicast and then a specific port only. So let's check. So we get the correct answer for this example activity. So you can try this one after you watch this video. Just log into your NetAcad account and then try all the questions first before checking the answers. So for 2.2.1, okay, collision and broadcast domains. So in the previous topic, you gain a better understanding of what a switch is and how it operates. So this topic discusses how switches work with each other and with other devices to eliminate collisions and reduce network congestions. So the term collision and congestions are used here in the same way that you use them in a street traffic. So when you say collision and when you say congestion, okay, for example, in San Isidro, dun sa may tulay, when there's a collision or congestion, so your travel time from Main going to San Isidro is longer kasi nga yung traffic masyadong mabigat. So same thing with the internet, same thing with network. The more users using the same traffic, it means it results to collisions and congestions. That's why during the daytime, where especially nowadays, where the classes are being held online, so there are the users from 8 a.m. to 5 p.m. The number of users is actually higher compared to the night time. That's why the traffic or the internet connection during daytime is slower, compared to let's say around 8 p.m. to 5 a.m. and so on. So in legacy hub-based Ethernet segments, network devices competed for the shared medium. So the network segments that share the same bandwidth between devices are known as collision domains. Then when two or more devices with the same collision domain try to communicate at the same time, then that will be the time collision will happen. So if an Ethernet switch port is operating in half duplex, each segment is in its own collision domain. There are no collision domains when switching ports are operating in full duplex. However, there could be a collision domain if a switch port is operating in half duplex. So again, we talk about on the chapter 1 on how to set up a router on a duplex mode. So you can just type duplex auto for automatic duplex mode, or you can just type in the full duplex or half duplex. So by default, Ethernet switch ports will auto negotiate full duplex when the adjacent device can also operate in full duplex. So if the switch port is connected to a device operating in half duplex, such as a legacy hub, then the switch port will operate in half duplex. Again, that's the meaning of auto negotiate or auto negotiation. For example, you're configuring switch 1 and you don't know the configuration of the duplex mode of switch 2, then the best way for you to do is to configure auto negotiation. Okay, so that whether the switch 2 operates in full duplex or half duplex, your switch will automatically switch from full or half. It depends on the switch 2. Then the speed then, for example, your switch 1 is only capable in sending 100 Mbps and the other switch is capable in sending up to 1000 Mbps. Auto negotiation will check, okay, will match the speed, the highest speed here, and then if that speed is also present on the second device or switch. So that's the collision domains. For broadcast domains, a collection of interconnected switches forms a single broadcast domain. Then only a network layer device, such as a router, can divide a layer 2 broadcast domain. But nowadays, not only router can do that task. Even the layer 2 switch, okay, can also do the division of broadcast domain. So routers are used to segment broadcast domains, but will also segment a collision domain. So when a device sends a layer 2 broadcast, the destination MAC address in the frame is set to all binary ones. Then we have here an example. So from our server, it sends a packet to switch, and then that switch will broadcast. Okay, just like in our example here, the switch 1 receives a packet from our server. So now on the first example, it's the topology contains only a server, switch, and 4 computers. Then the sender is our server. So this is the ingress port. It means the switch 1 now will create a broadcast, or will broadcast the frame. It will send the packet or the frame to all ports connected to our switch except the ingress port. Okay, so for example here, the difference from the first example to the second example, on our switch 1 there is another switch connected to it, okay, to the another port. Then again, S1 will broadcast the frame, and then that frame casted to the switch 2 will also do the same thing. It will also broadcast the frame to all ports connected. So since this is the ingress port, it will not or the packets will not be sent to the ingress port. So that's the broadcast domain. Now when a switch receives a broadcast frame, it forwards the frame out each of its ports except the ingress port, as I've discussed earlier. So alleviate network congestions. So LAN switches have special characteristics that help them alleviate network congestions. By default, interconnected switch ports attempt to establish a link in full duplex, therefore eliminating collision domains. Each full duplex port of the switch provides the full bandwidth to the device or devices that are connected to the port. For full duplex connections have dramatically increased LAN network performance and are required for 1 Gbps Ethernet speed and higher. So nowadays, as you can see, we're using fiber connections. That's why if you really want to enjoy the bandwidth or the speed of fiber, you also need to change your network adapter, probably from UTP cable to fiber also, or you may change your Wi-Fi adapter into 5 gigahertz. Again, we mentioned already the difference between 2.4 gigahertz and 5 gigahertz. As raised by your classmate a question, why when they go outside their house, the Wi-Fi, is getting weaker. Again, that's not the 5 gigahertz, that's the 2.4 gigahertz. 2.4 gigahertz is lower, but the range is bigger compared to 5 gigahertz. Okay, so switches interconnect LAN segments, use a MAC address table to determine egress ports, and can lessen or eliminate collisions entirely. Now we have these characteristics of switches that alleviate network congestions, including the following. First, the fast port speeds. Ethernet switch port speeds vary by model and purpose. For instance, most access layer switch support 100 Mbps. So this is the fast Ethernet, and 1 Gbps, or the gigabit Ethernet. Again, for example, the switch that supports gigabit Ethernet, okay, costs you more compared to fast Ethernet. For example, the fast Ethernet switch, 24 ports, will cost you around 3,000 pesos. But for gigabit Ethernet switch, they will cost you around 10,000. So that's the price difference between the two type of switches. But nowadays, there are also switches, or the core layer and data center switches. Could you imagine, they can support 100 Gbps? So they can forward 100 gigabits per second. So that's the speed of the data centers, just like in Facebook and other tech giants or tech companies. So switches with faster port speed cost more but can reduce congestions. That's the good thing about the faster port speeds. Now for fast internal switching, switches use a fast internal bus or shared memory to provide high performance. Okay? And then we have the large frame buffers. We use large memory buffers to temporarily store more received frames before having to start dropping them. So that's why for the ingress, this enable the ingress traffic from a faster port to be forwarded to a slower port 100 Mbps. Okay, they can store everything, without losing any frames, and then forward it to a 100 Mbps. Okay, then high port density switch lowers overall cost because it reduces the number of switches required. For instance, in 96 access ports were required, it would be less expensive to buy 2 48 port switch instead of 4 24 port. So again, the high port density, it means nowadays there are switches that capable in connecting 48 devices, or the 48 port switch, because before, the switches that available in the market can only contains up to 24 ports. So nowadays we can buy switches that has 48 ports. So we have an example of understanding activity here on how do you understand the topic. For example, here, which port speed will auto negotiate between hosts with a 1 Gbps and 100 Mbps. So it means it's 100 Mbps. Then which device separates broadcast domains? So definitely that's the router. And then which two characteristics do LAN switches use to alleviate network? So we just talked about that recently. One is the fast internal switching and fast port speeds. So let's check. Okay, again, we got all the three answers correct. Okay, so let's move to the last topic for chapter 2. This is just a module practice, and basically this is just the summary. So time check the recording. Okay, so there's no time. Okay, there. It's only 34 minutes. So what we've talked in chapter 2 is the frame forwarding, which have talk about the MAC address table. Then the switch domains, or the switching domains. We talk about here the half duplex and full duplex, and the segment is in its own collision domains. So basically there are no collision domains when switch ports are operating in full duplex compared to half duplex. And then there's a quiz here, 14 items, so you can answer them. Okay, again, this is not graded. For chapter 2, we don't have any packet tracer activity. Now, since it's our midterm exam on Saturday, let's check our schedules and requirements. So for packet tracer activities, we have here chapter 1. So we have 4 packet tracers that I guess you already answered this morning or yesterday. And then for chapter 3, we have another 6 packet tracer activities. So I guess for midterm, we can only cover chapter 1, 2, and 3. And the midterm exam is already done. Okay, so your midterm exam is already made. We have 60 points. Then I guess 50 items because some of the questions uh, are 3 points. No. So in that case, you are only required to submit to me these 10 packet tracer activities: 1.3.6, 1.4.7, 1.5.10, and 1.6.1 for chapter 1. Then for chapter 2, we don't have any packet tracer activity. So for chapter 3, we have 3.1.4, 3.1.2, or 3.2.8 rather, 3.3.12, 3.4.5, 3.5.5, and 3.6.1. So probably this afternoon we'll answer, no, I think 2 of these packet tracer activities while discussing the chapter 3. Then the quiz for chapter 2 and chapter 3 will be given to you by Tuesday, and the deadline of the quiz 2 will be on Wednesday. Then again on Saturday we'll have our midterm exam. Okay, so that's it, I guess. So if you have questions, you can just simply message me in Teams or in FB, and then good luck. See you this afternoon.